Hello everyone who's watching this video. This is my first YouTube video, and today I'm going to be speaking about AI, that is artificial intelligence, in reference to a tax transportation project. Please like this video, subscribe my channel. I'll be bringing for you big content. So we start off quickly. The problem that I'm going to solve here is inefficient transport system that is related with the taxi transport project that I'm doing. The problem in it is inefficient transport system. So in this problem, we see many people are inconvenienced with transport means that they can use to reach their destinations. Some have to walk long distances to catch the bus or train to make it to their place of work. So eventually people face delays, and also there is wastage of time, and some transport means are not user friendly, like those transport means which are congested. Let's say for instance taxis. Many, you might find people like the fat people are not so, don't find the taxis very friendly because there is a lot of congestion. So it's really disturbing. And there are people who are disturbed by sicknesses, and let me say in the night, they require a quick drive to hospitals and cannot access means quickly. So most of them are even delayed by traffic jam if they do access the means of transport. So therefore, the system I'm coming up with is here to ensure efficiency and effectiveness in the transport sector. So I believe that the above problems I've mentioned will be eradicated, at least reduced. People will be able to reach their destinations in time. They make payments easily. Yeah, we continue. So how am I going to apply artificial intelligence to solve this problem? AI will be used to figure out the fastest route utilizing maps, let's say from the pickup point to the destination point. Let's say one is traveling from Makere to Nakawa. So the AI can help one to figure out which is the fastest route. Let's take, for instance, one might pass Kamocha side and the other one might choose to pass from the city side. So which is the shortest route? AI can help us figure out which is the shortest distance and the time. It can predict the time. So I'll use AI to do this in this project. AI also will enable drivers to avoid routes with traffic jams, thereby saving the time. Yes, so AI can predict that here there is a lot of traffic according to the time. So therefore, drivers are able to know which kind of route they are to take so as to save time, their time, and the customer's time. So AI will also enable customers to know the fares to their destinations before ordering for one. Yeah, and therefore this enforces early preparedness for journeys and its timekeeping. So what data types am I going to use in solving this problem, the inefficient transport system? I'll be capturing the distance from the pickup point to the destination point. That is numerical. It will be numerical data. And I'll also consider time. I'll consider time, that the duration from the pickup point up to the destination, that time that is going to be there, the duration that one, the driver will spend driving the customer. I'll also consider the pickup, the wait time of the customer. Like if the customer makes an order, makes an order for a cab, let's say orders for a cab, how long are they going to wait until that cab reaches their pickup point? So I also consider that time, which is also numerical. I also consider the fare as which are prices. Like how much is one going to pay from a certain place up to their destination. I also capture that data in this case. Yes. So furthermore, we've heard of supervised versus unsupervised learning. Although you haven't heard of this, but these are terms in machine learning. So supervised learning is a machine learning is a machine learning paradigm for problems where the available data consists of labeled examples, meaning that each data point contains features and an associated label. So we are comparing that to, whereas unsupervised learning is a machine learning paradigm for problems where the available data consists of unlabeled examples, meaning that each data point consists features only without an associated label. So in this, we see that in supervised learning, we already have labeled data. The data is already labeled. So the model already has the data in place and it is already labeled. But in unsupervised, the model is going to learn how to distinguish the different data sets by itself. That is unsupervised learning. So you can take supervised learning as a kid who learns in the presence of a teacher, and unsupervised where one is like teaching themselves. Yeah, to break it down a little bit. So we continue with the differences between supervised learning and unsupervised. As I have said, supervised learning algorithms are trained using labeled data. So the data is already labeled. Then unsupervised learning algorithms are trained using unlabeled data. Data is unlabeled. So supervised learning model takes direct feedback to check if it is predicting correct output or not, while unsupervised learning model does not take any feedback. So supervised learning model predicts the output, while unsupervised learning model finds the hidden patterns in the data. So in supervised learning, it's possible, is provided to the model along with the output, while in unsupervised learning, only input data is provided to the model. So we see in supervised, the model is provided output, while unsupervised learning, only input data is given, like only input, but in supervised, you have output as well. So supervised learning can be categorized in classification and regression problems, while unsupervised learning can be classified in clustering and association problems. We shall see more of this in the coming slides. So we have techniques of supervised learning. We'll break down supervised learning. And I'm going to relate this with the project that I'm doing. So regression is one of them. Regression is a mathematical approach to find the relationship between two or more variables. Yeah, that is regression in AI. It is used to predict behavior of one variable depending upon the value of another variable. That is the output. The output variable, like what you get from regression, is always numerical. So basing on my project, I have a variable of distance, which is from the pickup point of the customer to the destination. And I also have the time, that is the duration, like the cab takes from the pickup point to the destination point. So in this case, my independent variable is the distance. and the time is the dependent variable. So time depends on distance in this case, and our output will be numerical. That is from the regression side. The second one, the second technique of supervised learning is classification. This technique is used to identify the category of new observations on the basis of training data. In this, a program learns from the given data set and then classifies new observation into a number of classes or groups. On the view of my project, the data set would be distances that are going to be categorized into short and long distances. So techniques in unsupervised learning. We expound more on unsupervised learning. We have clustering, a way of grouping the data points into different groups consisting of similar data points. It does it by finding some similar patterns in the unlabeled data set, such as shape, size, color, behavior, and so on, and divides them as per the presence and absence of those similar patterns. So according to my project, I can use the clustering to group vehicles basing on the capacity, like how many people can that vehicle carry. So I'm going to group those that can carry many passengers. That will be one category, that will be one group, and those that can carry, let's say one individual, or two less individuals, that will be another category, another group. Yes, I continue to association learning, a rule-based machine learning and data mining technique that finds important relations between variables or features in a data set. It tries to find some interesting relations or associations among the variables of dataset. According to my project, I can use association learning to find relations between the distance and the fare, like the fare, one page. So the longer the distance, the higher the fare one must pay. So we encounter some challenges while in this AI project. So there are AI technical challenges in my project, and these are one of them that I'll look at a few. Poor traffic predictions. The AI may face difficulties in predicting traffic congestion in some roads, and so it can at times give false information. This might arise from unpredictable happenings such as accidents, which can lead to blocking of roads, and so traffic congestion increases. The model is unaware of such happenings. So our AI is unaware of some happenings, let's say accidents that may happen. And so the AI might end up telling us to use that route as per what it knows that at such a time there is no traffic jam. But indeed, let's say an accident has happened and that road has been blocked. So there is a lot of traffic jam, they are still clearing. So that brings about confusion, and that is a problem. We have the bias problem. In case of development of new roads, the AI being biased to only directions that were put in it at the manufacture time, it takes very long to adopt into giving us, like recommending us to use the new routes. We have to retrain it, put in this new data. So it will take some time, and that is really not good. People need it to adapt quickly to changes like that. So we have also determined the right data set. Being difficult, the data inserted into the model is from untrusted sources, and so there is inconsistency in the data. Solutions to the challenges: the poor traffic prediction can be solved by using the congestion propagation patterns. It makes a series of connected road segments in the current time. So that's a solution to the poor traffic prediction. Then the bias problems can be solved by training the model on a wide range of data sets. They should not be one-sided like the data sets. They shouldn't be homogeneous. You should look at a variety, yes, from different sides. So we continue to look at accuracy versus recall versus precision and versus F1 score. Accuracy is the most intuitive performance measure, and it is the ratio of correctly predicted observation to the total observations. Here we look at parameters to evaluate the performance of the model. Whereas recall is the ratio of correctly predicted positive observations to all observations in actual class, that is all the negative and positive observations. So whereas precision is the ratio of correctly predicted positive observations to the total predicted positive observations. And finally, F1 score is the weighted average of precision and recall. So it takes, in this case, it will take both false positives and false negatives into account. So AI evaluation metrics. We have classification accuracy, which is the ratio of the number of correct predictions to the total number of input samples. So you have your input samples, which are data sets, and you will have the correct predictions, like on what you predicted, you could get the correct side over the number of input. We also have logarithmic loss, which works by penalizing the false classifications. So works well for multi-class classifications. The classifier must assign probability to each class for all the samples. So here, the evaluation metrics will help us to measure, let's say, accuracy. How good is our model that we've built? We are going to evaluate our model after building it. And these are, finally, this is a link where one of the links where I gathered my knowledge from. Yes, you can follow it and you can get to know more about what I was explaining in this video. Thank you. We meet next time.